So to summarize, Pathland talked about what if only one person is using the system with no other constraints on the resource utilization, and how Pathland can help to find out problems early in the life cycle, which in turn can help you to avoid major grid sets and save web applications from performance problems. So let's look into concurrency as the next one. So what does concurrency mean? So in the previous case, we discussed of a scenario where there's only one person traveling in the road. Now, as I was mentioning, that's not the practical case. Road is not really meant for just one person to travel. There are going to be multiple people traveling on the road, and in fact, there are going to be multiple lanes. Depending on the road, there could be multiple lanes, single lanes, etc. And as I was telling you, it's important because no application is going to be used by just one person. And most of the hardware, operating system, middleware applications are built to support concurrency. Now, what does this mean to the developer? Again, I was writing a piece of code. Thinking parallelism is very important when it comes to writing code. Now, why is it important? It is important because every piece of code either goes and alters some data, updates some data, either within the data structure in memory or in the databases. Now, if this parallelism is not considered, there is always a notion that we can do anything and everything with data. But when parallelism comes into picture, one thinks of what if other person tries to access the same data? Do I need to lock it? If I lock it, what is the impact of the other people using it? Right? It's same as we have multiple lanes, we have multiple vehicles traveling on the road. But what is its impact when it comes to a traffic jam? What is its impact when you find a tunnel, or what is its impact when you find a toll booth? Right? If you really see the speed or the time that you're going to take to reach from point A to point B depends not only on the speed of the vehicle and the driver, but it also depends on the speed and driver and the other conditions of other vehicles also. So thinking concurrency during design phase is very important, and if it's not done, it could lead to a position. Again, to take an example, a designer could think, I'm going to take files one by one and process it. Versus, I'm going to fetch multiple files together and process them parallelly. Now, even if you think of concurrency, even if you think of multiple people traveling on multi-lane traffic, one thing that needs to be considered is it's not the same number of lanes throughout. You're not going to be on a highway with 4 roads from point A to point B. We may have to take an exit, we may have to pass to the tunnel, or we may have to stop at a toll gate, or we may even go to a single lane road. So similarly, in the web-based application also, a transaction can go through different level of parallelism at different component level. Now, it's very important to remember that when all these transactions can go through parallelly, it's not going to be at the same level of parallelism throughout, and therefore we need to take into account that what is the speed at which you can travel, and consider all this when it comes to response time. And what will help us to visualize this? Typically, drawing call flows can help us visualize what are the different milestones of the transaction, which are the places where we can hit these tunnels or traffic jams, and what can be done about it. If not done, what would happen is it could go to a virtual level as if,